Welcome to MATLAB Tutorials, brought to you by Engineerize.com, where we engineer your rise. This week we are going to look at arrays and matrix manipulations. If you know your maths, you have probably encountered them already. An array is basically a list of numbers arranged sequentially. Arrays can be one-dimensional or two-dimensional. In MATLAB terminology, one-dimensional arrays are generally called vectors. Horizontal vectors are called row vectors and vertical vectors are called column vectors. Defining vectors. Vectors are defined the same way variables are. For a row vector, we type rv equal to third bracket 6 space minus 1 space 9 space minus 5 space 2 ending third bracket, enter. Third brackets or square brackets denote the starting and ending of the array. Each space in between denotes a separate column of element in the array. Like we learned previously, putting a semicolon at the end of the statement will stop MATLAB from displaying an output. For defining a column vector, we type CV equals third bracket 6 semicolon minus 1 semicolon 9 semicolon minus 5 semicolon 2 ending third bracket. Everything is same here too, except each of the semicolons within the square brackets act as a line separator. That is, each semicolon creates a new row. So when we press enter, we see a column vector with one column and 5 rows. Addressing vector elements. We can address the nth vector element simply by typing the vector name followed by n within brackets. It is the same for both row and column vectors. So let's try it. rv3, enter, and we get the third element in the row vector rv. cv1, enter, and we get the first element in the column vector cv. We can also select a range of elements from a vector. Typing m:(n) in place of the element position selects the elements from the mth position to the nth position. So typing rv2:4 displays the elements from second place to fourth place. But what if we needed a discontinuous range? A discontinuous range can be thought of as a collection of many ranges. For example, to select the highlighted range from rv, we have to use the command third bracket rv1 space rv3:5 ending third bracket. Now let's move on to the two-dimensional arrays, which are generally called matrices. A matrix is entered in a MATLAB row-wise. The rows are separated from one another by semicolons, and each element in a row are separated by spaces. So to enter the shown matrix, the command will be A equals third bracket 0 space 4 space minus 1 semicolon 6 space minus 8 space 2, enter. Addressing matrix elements. For addressing a particular element of a matrix in the mth row and nth column, the command is matrix name followed by the row position and column position within first brackets. For example, A23 returns the element at the intersection of the second row and third column, that is 2. If we want all the elements on the second row, we replace the column number with a colon. The same applies if we want the whole third column. To select a range of elements of the matrix, the syntax is matrix name followed by m:(n), p:(q). This command will select the elements in the row m through n and columns p through q. MATLAB stores two-dimensional arrays in the memory column-wise. So the command A5 will return the fifth element column-wise. Now let's look at ways to define some special vectors and matrices. Suppose you need a vector containing all integers from 31 to 50. You can simply type x equals 31:50. This will return a vector containing numbers starting at 31 and gaps of 1 till 50 is reached. You can set the gap between elements by 0.5 by typing y equals 31 colon 0.5 colon 50. Notice y has double the number of elements x has. This is useful when you know the start and end points and also the difference between consecutive elements. If you don't know the gap but know the number of elements you need, you can use the linspace function. X equals linspace 30, 50, 25 will create a vector with 25 equally spaced elements starting at 30 and ending at 50. If you don't specify the number of elements while using linspace, it will generate 100 equally spaced elements. You can get a 4 into 4 null matrix by typing zeros 4. You can get a 2 into 2 identity matrix by typing I2. Now let's look at some matrix operations. While performing matrix operations, you must be careful about the order of the matrices to avoid any error. Addition and subtraction are very simple. Type A plus B or A minus B. Note that the size of A and B must be exactly same. Next, matrix multiplication. For this, let's take a column vector C. Look at this new way of defining column vectors. Define a row vector and then put an apostrophe for transposing it. Okay, so A into C. Here the number of columns of first matrix A must be equal to the number of rows of the second matrix B. Matrix division A by B. This command is same as A multiplied by the inverse of B. This is called right division. Left division is done by typing A backslash B, which is same as A inverse multiplied by B. There is also exponentiation. A raised to the power 3. This can be used for square matrices only. Moving on to element by element operations or array operations. Here the operations are performed between corresponding elements of two arrays of same size. It is denoted by a dot before the operator. So if you want each element of A multiplied with their corresponding elements in B, type A dot asterisk B. Similarly for division and exponentiation. It is very important to use the correct kind of operation. Missing out the dot may cause unexpected errors or wrong results. For example, say we have a vector x which contains all the numbers from 0 to 10. If we want to store their squares in a vector y, you might write the command y equals x to the power 2. But this would mean square of the vector x, while we want the square of each element within x. So we must put a dot before the exponent sign to denote that it is an element by element operation. We can add or delete rows and columns from a matrix. Suppose we want to add the column vector C at the end of A. So we'll type A equals third bracket A space, because space separates two columns, then C, the new column, ending third bracket. To delete the second column of A, the command would be A colon comma 2, that is all the rows of second column equals starting and ending third brackets, that is null. I'll leave it to you to guess how the same works for rows. Next we will look into some matrix functions. You can inquire the size of a matrix using size function. It returns the number of rows and columns. The length function does the same for vectors. You can find the mean, median, sum, maximum, minimum, even standard deviation of a vector's elements using their respective functions. You have already seen the use of inv function to find the inverse of a matrix. DETA calculates the determinant of matrix A. There is also functions for finding rank, eigenvalues and eigenvectors of a matrix. You can find the scalar product of two vectors using the dot function and the cross product of two vectors using the cross function. MATLAB makes our job easy by providing a number of matrix operations and functions, which can be used to solve complex equations. For example, let's solve this system of linear simultaneous equations using matrix method. From the equations, we have a coefficient matrix A, a variable matrix X, and a constant matrix B. The system of equations is represented by Ax equals B, and the solution is x equals A inverse multiplied by B. Let's try the same on MATLAB. This week up to here. Next week we are going to begin programming in script files or M files.